a new day. Welcome to GalaxySpaceTalk. On today's podcast, we will be talking about stars formation. That is how stars are formed. My name is Nanekia JC, and with me here are my guests, Charles Dazi and Solomon Agbeli. You are welcome to today's podcast.
Thank you.
Yeah, thank you.
Okay. So, talking about formation of stars or stars formation. First of all, what is a star?
Okay. Okay. Today I'm wearing a shirt that has a lot of stars inside, all the colors of the stars.
Okay.
Yeah, so we have a yellow star, we have a red
Yeah.
star, giant star. We have a blue star as well, which is very hot as well. So a star, and first example, the sun is a star. That is one thing a lot of people don't know. That the sun is a star, and all the stars we see in the sky take the same formation of the star. So the star is actually a huge ball of gas that has been resulted from fusion of hydrogen atoms. Right. So when we talk about fusion of hydrogen atoms, we're talking about the fact that you are fusing two nuclei of the same charge. So you can imagine holding a magnet, same like positive, and you are trying to push it together. You see, it's very difficult to put them together unless you turn and put the positive and negative. But with fusion, they are of the same charge. So they fuse together over millions of years and then they explode. But when they explode, gravity holds them down so that it doesn't come out. But this comes as a result of gas clouds, dust, which occur across light years. So these dusts come together, they form a huge mass. And when you have a huge mass, you're talking about gravity. So gravity handles these clouds of gas and the particles, squeeze them together, thereby creating a hot core.
Okay.
So the hot core is where we spoke about in our other part, the primordial gases, with regards to the hydrogen gas. So now the hydrogen gas nuclei start fusing. And when they fuse, they expand, they blow off. But the gravity is so much, so the gravity holds them in place. So stars are formed from clusters of gas clouds, dust, and particles, which have been fused together under gravity, increasing the core temperature and thereby causing fusion reaction.
Okay. All right. So talking about the sun and being a star and other luminous bodies being star. Normally, we know that a star has four figures or something. The way we draw star on Earth. Yes. How is this so, and how does that compare to what is up there?
Okay, so remember in our podcast about scattering of light, where we talked about how light travels in the straight line in space. Well, when the light comes from the star and it hits the atmosphere, because it scatters, or because of the difference between atmosphere and um, space, it refracts. Now that refraction causes the light to become like a twinkle. That's why we see stars twinkling in the
Yeah.
night sky instead of them in their round form. It's all because of the refraction of light due to the atmosphere.
Okay. So stars are actually round,
Yes.
but they twinkle because of refraction from the Earth's atmosphere. Okay. With that said, what role does gravity have on stars?
Yes.
Stars formation.
Yes. As I explained earlier, once you have the gases, the clouds of gases with massive masses, when we talk about, we'll use the term solar mass, right? When we say solar mass, we are talking about 80 times of Jupiter, right? You need that to form the smallest star. You can imagine how huge Jupiter is. So if you talk about 80 Jupiters to form one solar mass, so you can imagine the gases, the clouds of gases, and then the dust that are coming together. They are very heavy, very heavy. So gravity likes mass. So like on Earth, because the mass of Earth is is quite heavy, we have gravity. When you go on Jupiter, I'm sure you can't take a step because the gravity is crazy. When you go on the moon, you can jump because the moon has
Okay.
relatively smaller. So when these gases come together, gravity starts playing a role. So the gravity actually squeezes these clouds to form the core, the hot core, for it to allow for the fusion of the hydrogen nuclei, right? And when they fuse, they one of the fused nucleus decays.
Okay.
One of the fused protons, they are protons of positive charge. One decays and becomes a neutron, and it adds up to the proton to form another sort of nucleus. So now it is not two protons, it is a proton and a neutron. And these will form, and these will also interact again as new fuel to also push out more energy. But then gravity just keeps them holding. So there's equilibrium. So this is trying to gush out energy, gases, heat. Gravity is pulling down on them. So gravity plays a very important role in keeping them in place.
Okay. Gravity plays a key role in keeping stars in place, as said. Okay. So with the formation of star, how does it begin and how does it end?
Okay, so basically what happens is that clouds of gas and dust start to gather together. Now, they form what's called a molecular cloud. That's a cloud of basically just gas, hydrogen and helium and other elements. Now, over time, gravity pulls this together. As you said, it's about 80 times the mass of Jupiter. So it's a very big cloud. After it's being put together, because of all the matter packed into such a small space, it becomes very dense and very hot. And that starts nuclear fusion, which has already explained. And basically, we have a new star being born.
Okay. So when you talk about protostar, what is a protostar?
So a protostar is that dense core that I talked about. When gravity drags all those gases together and they start to ignite and become very hot, that is a protostar,
Okay. So that's the beginning of
a star.
a star. Okay.
And as you said, I think in your other question, you're like, how a star is built and how does it die?
Yeah.
Of course, stars die. That is, they die to form white dwarf stars, die to form huger stars, form what, black holes, etc. And they go through that process, as I said, burning hydrogen to helium. The helium becomes a new fuel, burns for another 1 billion years, burns it into carbon and oxygen, right? But for a smaller star, carbon and oxygen can't fuse because they are bigger nuclei. So then the core begins to shrink more. As the core shrinks more, the outer space, now we are left with just a bit of hydrogen and oxygen, hydrogen and helium. They will form a small shell around the inner core made up of carbon and oxygen, which has been formed through the fusion. So finally, they will give off their last strength, as in those ones, and then sort of make the star become red, glow, and cools down. That is what we call the red giant star, right? So at this stage, it is cooled down. Sooner or later, the inner core will again, the outer core, which is the red, will contract again based on its, as helium is being used, helium is burning. It's the fuel. It will burn out, just like our star. One day it will burn out. Some billions of years to come, it will expand, get into a red giant star, get into a blue star, and then probably become a white dwarf feature. But these things will happen over billions of years. So the funny thing is, we are enjoying photons of light that were produced 10 million years ago, right? So these are some of the facts about the sun. We are not just enjoying it today's fusion. It's a 10 million year fusion that we are enjoying the sun now.
All right.
And,
Are there types of stars? And if yes, can you mention some of the types of stars?
Okay, so I think he has already mentioned a few. We have
Yeah.
the neutron stars, we have white dwarfs, we have blue stars, and we have the normal yellow stars like our sun. So the red dwarfs or the white dwarfs, they are basically stars that they are already down their main sequence. So they have cooled off, they've spent all their oxygen, they are just burning the remaining. They are living on borrowed time. Let me put it that way. Then we have the blue stars. Now, the funny thing about stars is that the bluer you are, the hotter you are.
Okay.
So
So bluer the hotter.
yes, bluer the hotter.
But red is not like that.
No.
Wow.
So
Okay.
red is actually cool
Mhm.
in star terms. Red is very cool. So the blue stars are gigantic. They have massive amounts of fuel to burn. So they produce they produce a lot of nuclear fusions. They have a lot of energy. Then we have normal stars like our sun, yellow in color. They also have energy, but they don't live as long as the smaller stars, which are the red dwarfs. Now the red dwarfs, they also use hydrogen and helium. They don't have as much energy, so they don't burn as fast as the blue stars or the yellow stars. Now, the bigger a star is, the more likely it will run out and die. So maybe a blue star might burn for maybe 200 billion, maybe 2 billion years and then die out. Our sun will continue burning for 10 billion years and then die out. But a red dwarf star might continue for maybe as long as 30 billion, 40 billion years, and it's still going on its main sequence
Okay.
because it doesn't burn its fuel as fast as those gigantic stars. So basically, the type of star you are depends on how much fuel you burn.
You burn. Okay. So with that said, those that we see at night, what kind of stars are they?
Well, I will term them as our yellow stars, but you can't unless you're an astronomer or you look through, as we have the James Webb Telescope that can identify these kind of stars. For us, we can only see them twinkle
Yeah.
through the refraction as it comes down. But through the James Webb Telescope, Hubble Telescope, we're able to view some of these blue stars, red stars, um, the yellow stars, and all. To add up, and what he said was very interesting about the very big stars. Now, the very big stars, it burns more fuel because there's more heat in the center and there's more gravity. So it is burning out faster. But the good thing about these big stars is when they collide, or when I said probably you have a neutron star colliding with a neutron star, or when they form the black holes, or they're able to produce elements, very heavy elements that are above the periodic table, like 26. So some of the huge stars, the center core are able to fuse, continue fusing. Carbon and oxygen will come, they're able to burn because there's so much heat. And then you can have iron at the center. Some of these big stars, you can have iron at the center. So these stars can also produce a lot of elements after they die. They can produce silicon, can produce nickel. After the as you said earlier, supernova. We mentioned that later earlier, but yeah. So basically, that is one of those things that
So you were mentioning iron, nickel, and all that. So how does that help in our galaxy? I mean, star formation. Yes.
Yes.
How does it contribute to our galaxy? Because I know we mentioned galaxy.
When the star dies, the bigger ones go supernova and the small ones cool down. Now, when they go supernova, they release all their elements into the galaxy. And so these elements go on to merge and form other compounds like water, maybe from oxygen and hydrogen colliding, or maybe asteroids and meteors from heavier elements combining together. Another thing is that the shock wave from this supernova might push gas and dust together to form new molecular clouds, which leads to the birth of new stars in the long run. So yeah, the star's death is actually it just releasing everything it was made up of back into the galaxy, and then it leads to the formation of new stars and other elements.
Okay.
And there are a lot of elements in the universe and in our solar system and in our galaxy. Iron, steel, nickel. See, they are all in these rocks.
Yeah.
And NASA sometimes talks about them going to mine on some of these rocks and getting some of these things from there. They have spoken about it, how we can moon mine.
Yeah.
Some of the reasons they are going to the moon. They think they might find elements of importance that they can used to produce items on Earth. So they are in abundance. A lot of elements that have occurred through supernova and through neutron to neutron star colliding or neutron to black holes colliding. So they produce a lot of elements that are being used by us or are soon going to be used by humans. Yes.
Okay. All right. Please, do you have your any last words for us?
Okay, so well, star formation is very necessary, and it's one thing that is constantly happening in the universe. Fun thing about star formation is that sometimes, because of star formation, we can sometimes get new solar systems being formed. For example, our solar system came into being when the sun was formed. Um, After the sun was formed, the resulting energy caused the dust to gather together to form planets, to form asteroids, to form the gas giants. So all these are effects of star formation. It's a very destructive event, but yet a very necessary one for the continuing of the universe.
Okay. Such
Yes.
as.
I think you summarized everything. The formation of the sun is a very important thing for us. Of course, the sun gives us energy, gives us heat, and it gives us luminosity. So having to know its formation and how it comes about has also developed how we do things here. So as Einstein said, E is equal to mc squared. It was as a result of star formation. Two protons coming together, producing high amounts of energy. So with a little mass, you are squaring light. That's 300,000 kilometers squared times a little mass. It's produced a huge, that is why we get the atomic bomb and fusion reactions. Like how China recently said they've been able to create a fusion reactor that can behave like the sun out of its steady and formation. So it's a very important thing that is also guiding our lives and producing technology through its study and its formation. So it's very important. Very,
All
very
right.
important.
Thank you. So that's where we come to the end of star formation, how stars are formed. I hope you have also learned something from this podcast. We know that there are a lot of stars in the atmosphere. There are various types of stars, and even the blue star that we think that might be the one that we see are the ones that emit more heat. And the bigger the star, the more likely it is to die quickly. Let us keep that in mind and know that our star and even the sun is a star. Thank you for joining us for today's podcast. And thank you to Mr. Dazi and Mr. Gule for being with us throughout today's podcast. Your presence is really well appreciated. Till we meet again next time, don't forget to like and subscribe our YouTube channel and all our social media channel. Follow us as Galaxy Aeros GH. My name is Nanekia JC. Bye.